Hello, this is Jay Abbas, and this presentation is about IoT-based home automation solution. This is online IoT internship project, and we will also see what all we have learned as part of this internship in this presentation. Here is the content of this presentation. They are SDLC, embedded C, introduction to IoT, introduction to embedded systems, internship project, and working of this project. SDLC is Software or System Development Lifecycle. It is a standard process followed to implement a project successfully. If a project is successful, it means it is done with quality and in time. Here we can see in the image that SDLC is a cyclic process which consists of following steps like requirement analysis, design, implementation, testing, and evolution. There can be many more phases in this process. Number of phases in SDLC process completely depends on what type of project we are trying to implement. Like it can be hardware based, simulation based, or software based. Embedded C. Embedded C is used to program embedded systems. Here we will be using C and C++, which comes under embedded C to program embedded systems. As part of this internship, we have learned the uses of C, like embedded software development, OS kernel development, firmware and driver development, and so on. And also, we have learned basics of programming like data types, storage classes, conditional statements, loops, arrays, pointers, and strings. And finally, classes and objects concepts in C++. Coming to IoT and its components, we have gone through the definition of IoT, that is Internet of Things, and the factors helping IoT are are like cheap hardware, advanced software, and machine-to-machine solutions, and some more. We have also seen general technical requirements for IoT along with the challenges of IoT and its solutions. Some of the challenges are like addressing to the lot of devices connected to internet, addressing a big challenge. So we have used public and subscribe model to overcome this challenge, and data volume due to large amount of nodes and systems are being connected to our internet. They will produce large amount of data. We have used cloud storage to overcome the data volume challenge. And now coming to embedded systems and its components, similar to IoT, we have gone through the definition of embedded systems and understood the difference between embedded systems and general purpose systems. We have learned about different components present in embedded systems like memory, controller or processor, sensors, actuators, and control units, and etc. We also seen how we interface all these components in the form of block diagram. Now let's get into the internship project, that is IoT based home automation solution. Here we have programmed Arduino Uno and implemented this project using SDLC process. As we know, SDLC is standard process to build a project, and we have used a Blink server to operate and monitor the system remotely. There are different peripherals used, and they are LCD display, that is characteristic liquid crystal display, and temperature system, which is used to read the temperature values and control the heater and cooler, LDR sensor, which is used to monitor the light and control the garden lights, serial tank, which will use to simulate the water tank, and Ethernet module to connect to the Blink console. Requirements for the project are: we need a simulator, that is PiximLab, Arduino IDE to program Arduino, null emulator, and Blink Cloud account. And coming to the working of this project, this IoT solution mainly performs three functionalities. They are function 1, controlling garden lights, that is LEDs, with respect to the sunlight, which is measured with LER sensor. Function 2, automating the control of heater and cooler in the temperature system with respect to temperature reading. Function 3, monitoring water levels and automating the inlet and outlet valves. Here, we will be using serial tank as water tank. All these systems will be automated, and even we can control it manually. And from these functions, we will analyze the requirements and implement based on the requirements in standard process. This is the image of the setup includes LCD display with I2C module, LER sensor, LEDs, temperature system, and Ethernet module. Now, let's get into the live demo. This is the project setup for this IoT-based home automation solution. Here we are going to use Pixian Lab to program Arduino-based IoT solution. Now when I go to modules, spare part section, we can find all the peripherals required for this project, like LCD display, temperature system, Ethernet module, LDR, sensor, LEDs, and serial tank is used to simulate the water tank functionality. Here we can see LCD display with the help of with this communicated to Arduino with the help of I2C module, in which we can find the temperature reading and volume of the water tank reading. Along with that, we can find the commands that are executed from the app we have built, and the temperature system, which consists of heater, cooler, and temperature sensor. And these are LEDs, which we are going to control with the help of LER sensor. This is LER sensor, and this is Ethernet module, which is used to connect Arduino to internet and to the Blink console. Now let's see the first functionality of our project, that is controlling a garden light automatically. Now I'm going to reduce the LER sensor output. As we can see, when I'm going to reduce the LER sensor output, the LED brightness has decreased. That means the light outside is very high. That is since we don't need the LED lights. Now I'm going to increase the LED sensor output, and that means the light outside is very low, so LED is turned on. In this way, we can automatically control the LEDs with the help of LER sensor output. Now let's see the functionality of temperature system. To see the functionality of temperature system, we need to go into the app which we have built in the Blink console. And this here in the left corner, this will represents the app which we have built in the Blink console, which consists of two tabs. In the first tab, there is it represents the temperature reading in the form of gauge and the control button for heater and cooler. Along with that, we can find notification bar where we can get the notifications when the threshold values are met. And in the second tab, we can find the water volume reading in the form of gauge and control buttons for the outlet and inlet valves. Now let's see the functionality of temperature system. Now we're going to on the cooler. We can see the cooler in the temperature system is turned on, a fan will start rotating. I'm going to off the cooler, the fan stops rotating. I'm going to on the heater. Now temperature reading start increasing. As we set the threshold value 35 degrees, we automatically turns off the heater, and temperature gradually decreases when it crosses the 35 degrees. And we can also get the notification in notification bar that is turning off the heater as temperature is above 35 degrees. Here we can also get the commands beside the temperature reading, the heater is turned on or heater is turned off, or cooler is turned on or cooler is turned off. Now I turn on the heater. You can see heater on off, heater off, and cooler on, and it is turned off, cooler is off. Similar to that, we can find the commands which are executed for the inlet and outlet valves below LCD display. Now let's see the functionality of water tank controls. Initially, the water tank is full with its full capacity, this 3000 liters. Now I am going to turn on the outlet valve. Now the water will start draining. As you can see, the water is started draining and the water volume reading is also changing simultaneously with the current reading. And I turn off the outlet valve and the water stops draining and turn on the inlet valve. The water will start pumping up into the water tank. And here we say the threshold value has 3000 liters. This is a full capacity. When it reaches the full capacity, the inlet valve will automatically turn off. Now I'm going to turn on the outlet valve again. The water will start draining, and when it reaches the water level of less than 2000 liters, the inlet valve is automatically turned on and start pumping the water. As we set the threshold value to turn on the inlet valve at 2000 liters. As we can see, both the inlet and outlet valves are turned on. The volume of the water is constant. Now I'm going to turn off the outlet valve. Then the draining of water will stop and inlet valve will pump the water in. And similar to previous case, it will again stop automatically when the water tank reaches its full capacity. In this way, we can also find the notifications for when the water is less than 2000 and the inlet valve enabled and water is equal to 3000, inlet valve is disabled in notification tab. In this way, we can find and we can monitor and control the IoT-based home automation solution with the help of app which we have built in the Blink console. This is the entire simulation of this project. Thank you.